Okay, so today we are going to look at the graphs of quadratic equations and their solutions. So we've been solving quadratic equations. Well, now let's think about and look at what the actual graph of those look like. A lot of you know Desmos.com. That is a good online graphing calculator, and that's what I'm going to use. It's really easy to use. So if you want to use the online graphing calculator, go to Desmos.com. And when you go to Desmos.com, this is the home page, and all you have to do is just select the Start Graphing, and it will take you to the graphing calculator. So what if, how do we use it? What if we wanted to graph y equals 3x plus 4? That's not quadratic because it doesn't have x squared. What is y equals 3x plus 4? Hopefully you remember that that's just the graph of a line. So to use the calculator, if you want to graph y equals 3x plus 4, down here at the bottom, you can bring up the keyboard. And so just like on your graphing calculator at school, y equals, you don't have to enter. All you have to enter is the 3x plus 4. So you could just use the keypad to press the 3. Here's your x. And then plus 4. Right? And it gives you the graph of the line y equals 3x plus 4. And if you want to graph a second equation, like maybe 3x minus 6. Well, that blue line is 3x, but then if we add the minus 6, you see then that it gives us our second line. Alright? So you can add as many graphs on there as you want, just like with a regular graphing calculator. Okay? Well, let's think about what the graphs of these quadratic functions look like. So this would be an example of a quadratic equation, because now we see x squared in the equation. So let's go to our graphing calculator and go to our y equals, and now we want to enter 2x squared plus 4x minus 3. So there's the 2, there's the x. Now to square it, the a squared key will put an exponent of 2 on there, so it becomes 2x squared. And then we said plus 4x minus 3, right? So there is our graph, and over here you can change the size of the scale of your graph. You can see more or less of it. So there's the graph of 2x squared plus 4x minus 3, okay? Let's just try a couple of more quadratic equations. What about x squared plus 2? So you could enter x squared plus 2, and you have that graph. And what about 3, let's make it negative 3x squared. 3x squared plus 2x plus 1. There's the graph of another quadratic function. And one more, what if we said, what about 1/2 x squared, or 0.5 x squared? Minus 6x minus 4. Right? So there are 4 different graphs of 4 different quadratic functions. We'll look at those in a second. What do you notice about all of them? They're certainly not lines anymore, but what do you notice about the shapes of those graphs? They have a U-shape, don't they? Sort of. They all sort of have a U-shape. That U-shape is called a parabola. So you'll see that when you get into geometry next year. But yeah, the parabola is just that U shape that the graph of a quadratic function makes. Alright? So what we're going to be looking at today is you're going to be graphing some quadratic equations, and I want you to think about what the x-intercept is of those quadratic equations. So let's look at this one. What if you have y equals x squared minus 6x minus 7? Well, you now know that's going to make a U shape. That's going to be a parabola because it is quadratic. So let's go back to the graph and graph that, and it's asking us to think about what the x-intercepts are of this graph. So if we have x squared minus 6x minus 7, where are the x-intercepts? Remember, the x-intercept is the point where the graph crosses the x-axis. This is our x-axis here, the horizontal. So that point right there is one of the x-intercepts. It's at -1, right? And notice it has two x-intercepts. The other x-intercept is at 7. So this graph has two x-intercepts, -1 and 7. So we would say that the x-intercepts for that are -1 and 7. Okay? And that is what you're going to do today that will be new. Now, how do we solve this quadratic equation? Remember what we've been doing when we've been solving quadratic equations. What is it that we need to see in a quadratic equation? It needs to be in standard form, but what does it need to be equal to? It needs to be equal to 0, right? So if you've got an equation, if it says y equals x squared minus 6x minus 7, or f of x equals x squared minus 6x minus 7, and if it tells you to solve it, that just means that you need to make y equal to 0. So you would say 0 equals x squared minus 6x minus 7, right? And now that you've got it equal to 0, you could solve this by, you could try factoring. This would be pretty easy to solve by factoring. But the important thing to know is when it says to solve a quadratic equation, that means change the y and make it equal to 0, and then solve this just like you've been doing for the last week. Alright? So for your assignment, I'm going to give you some quadratic equations, and the first thing to do is to use the Desmos graphing calculator and graph the quadratic equation, and then identify the x-intercepts for each of the quadratic equations. Then after you have identified the x-intercepts, you will then solve the equation by changing y to 0 and then solving it and see what you get for the solution. And then lastly, after you get the x-intercept and after you solve it, then you will compare the x-intercepts with the solutions, and you're going to notice something. So I want you to talk about what you notice when you compare the x-intercepts and the solutions for each of these quadratic equations. Alright, so that's what you'll be doing today.